This is 8.5 circumference and area. Now, in previous years, you have gone over the circumference and area formula. We're going to kind of expand on that, but we are going to review. So, the circumference of a circle is defined as the distance along the outside of the circle. This is different than when we were talking about the angle measure of an arc. So, when I say a circle is 360 degrees, if I'm standing in the center and I'm looking somewhere and I turn all the way around, I've turned 360 degrees. But if I am at the center, that doesn't help me find the circumference. I actually have to be on the edge and I walk the distance. So when I say a degree, I'm talking about how far I've turned. If I'm talking about circumference, it's how far I've walked. And remember, the radius is equal to, or the diameter is equal to 2 times the radius, and so that's why both of those formulas will work. I typically stick with just this formula. I don't have the other one. I don't ever think about it. So to find the circumference of a circle, you're going to take 2 times pi times the radius. So in this first one, the radius is 5 centimeters. So the circumference is just going to be 2 times pi times the radius. And then we can use the calculator. So there's going to be 2 answers I'm looking for. The first one is I want to multiply everything before I deal with the pi. So I'm going to do 2 times 5, let's speed this up, is 10. And then we also have the pi. And then the units are centimeters. So that's going to be one of the answers we're looking for. But this is our exact form. And if we get an approximation to kind of what that is, so if I do 10 times pi, that answer is rounded. The calculator kind of cuts it off, and I also want that answer. We'll just round to the nearest tenth. So I want both answers, the one where pi is part of the answer and the one where we multiply the pi in. Okay, so for this next one, the diameter is 7. Well, if the diameter is 7, that means the radius is half of that. And this is in inches. So our circumference, if we were to walk around, is 2 pi times that value. So again, we're going to have our 2 answers. 2 times 3.5 gives me 7. Look at that. And it's inches. And then I'm also going to take that 7 and multiply it by pi. Now, if you don't have a pi button on your calculator, you can always just multiply by 3.14. So we're going to round that to 21. Well, the 9 rounds up, so it's going to be 22. So those are my answers. Okay. So we're going to expand from that. and say, what if I don't want to walk around the entire circle? What if I'm only walking around part of it? So that's where we're talking about arc length. So not the degree measure, not how far have I turned, but how far do I need to walk? So the arc length of an arc is the physical distance along the circumference between 2 points on the arc. So if I have a circle, okay, and I want just this much, so I want to start here and I want to walk, I don't know, to here. And I want to know how far that is. That's where we would use this formula. Now, it's a formula, but it's also kind of intuitive, where we're taking 2 pi r, which is the circumference of the whole thing, and we're multiplying it by theta divided by 360. That's because that's going to be our percentage of the circumference that we're looking at. Because remember, if I were to draw the radii in there, the percentage that this arc is just theta divided by 360. So I'm going to say, okay, take the whole circumference and multiply it by just that percentage. So for our example, what is the length of the arc if the circle has a radius of 4 centimeters and a central angle of 120 degrees? So you don't have to draw the circle, but 120 degrees, roughly that. So this radius is 4 centimeters and that angle is 120 degrees. We want the arc length right there. So the arc length, we're using S, is going to be 2 pi r times the angle divided by 360. Okay. Now, if you've got a calculator, a graphing calculator, you can type this in. Again, we want 2 answers here, one with pi and one where pi is multiplied in. So I'm going to do 2 times 4. And then there's 2 ways that I can multiply this fraction. I can do 120 divided by 360. Or I can also, and then once I have that, because I want this as a fraction, I can hit math 1. So that's my first option is fraction. I'll turn that into a fraction. So I'm looking for 8/3 here. Or 2 times 4. If you hit alpha, y equals, this is numerator denominator. I get to input the fraction how it looks right here. That's helpful. Oh, I did an 8, not a 4. There we go. So that's 8/3. So the way that we would write this answer is 8/3 pi or 8 pi thirds. And it's centimeters. So that's one of my answers. Now I'm going to take that 8/3 and multiply it by pi. Pi is an irrational number, so there's no way to put that value into a fraction. Centimeters. Okay, so that would be the answer. What is the length of the arc if the circle has a radius of 5 and a central angle is 40? So again, our formula is going to be, we'll find the entire circumference and multiply that by a percentage of what we want. So if the radius is 5 and my angle is 40, and then type it into the calculator. So 2 times 5 times alpha y equals 40 divided by 360. Now if your calculator can't put something into a fraction, you can always simplify fractions by hand. But this is going to give me 10/9. We still have that pi. I like to put that back into the numerator, and it's centimeters. And then I need to also multiply that by pi. So then that would be my two answers. Okay, now we're going to look at area. So we're finding the area of the entire circle. So the area of a circle is defined by the number of square units that can fit inside the circle. So that's, now I have a circle and I want to know the area it's going to cover. In fact, I actually used this formula earlier today when I have to try to buy a mat that my baby can play on, and I needed to make sure it was going to fit in the room. So I had to use it. Had to use area. Okay, so what we're going to do here is this is just pi times the radius squared, and I keep straight that this one is the squared because my units are supposed to be squared. So my answer will have centimeters squared in this one. So since my units are going to be squared, my radius is squared. So area is going to equal pi r squared, where in this case r is that 8 centimeters. So I want my two answers. The first one being 8 squared is 64. And then I also want where we multiply the pi in. So 64 times pi. And that's how you find the area. This is also helpful when you are looking at pizzas and deciding, I've done this where maybe 2 medium pizzas are cheaper than getting 1 large, or maybe 1 large is going to be cheaper than 2 mediums. It's all about the food, guys. Okay, sector area. So this is where, kind of like when we were talking about the arc length, where I only wanted a portion of it. Now I only want a portion of the area, so maybe I just want a slice of pizza. Same concept where I take the area formula and multiply it by the percentage of what I'm looking at in the circle. So what is the area of the sector if there's a radius of 4? And the angle is 120. So something like this. Okay, and I want the area of just that piece. So area of the sector is equal to, and then it's going to be pi r squared times the angle divided by 360. So I'm going to take my 4 and square that. That was a different color. Oops. There we go. So now I'm going to type in just this portion because I want my two answers. So I'm going to say 4 squared times 120 divided by 360. So I get an answer of 16 pi thirds, and the units were centimeters. And then when I multiply that pi in, I get 16.8. Okay, let's do another one. Now, what is the area of the sector if the circle has a radius of 7 centimeters and a central angle of 40 degrees? So now it's a smaller piece. Well, the area is pi r squared times the angle divided by 360. Well, my radius is 7 centimeters, so that's what goes here. And then the angle is 40 degrees, so that goes here. So again, my calculator, I'm going to do 7 squared times 40 divided by 360. Then I'm going to put that back into a fraction, so I get 49/9. So 49 pi ninths, and it was centimeters. And then I'm going to take that value and multiply it by 3.14. So those are my answers. Okay, we have one more type of problem. But this video is 20 minutes long, so I'm going to make a second video for this one. So now would be a good time to take a break.